AP Environmental Science. In today's video, we're going to be covering Unit 3.6 and 3.7, the phosphorus cycle and the water cycle. So in our last video, we were discussing nutrient cycles and how nutrients such as carbon and nitrogen cycle through the biosphere. Today, we're going to be talking about the phosphorus cycle and the water cycle. And I want us to take a look at this image for a second. This image is showing us how phosphorus is going to cycle through the biosphere. But if we look more specifically, we can see that the phosphorus cycle has no atmospheric component. Phosphorus is only going to be cycling between water and land. So the phosphorus cycle is the movement of phosphorus atoms and molecules between sources and sinks or reservoirs. And again, with the nitrogen and carbon cycle, we were talking about sources being things that add to the atmosphere. In the phosphorus cycle, again, there is no atmospheric component. So instead, we're just going to be talking mainly about long-term and short-term storage of phosphorus. And the main reservoir of phosphorus is going to be rocks and sediments. They're there for a very, very, very long time. So the phosphorus cycle is relatively slow compared to the carbon, water, and nitrogen cycles. This is because the primary source of phosphorus entering the water is going to be through erosion. This is going to be a natural way that phosphorus is going to be added into local waterways. Another natural way would be through erosion of animal waste and decomposition entering in the waterways. These would be natural. However, we look over here for man-made or anthropogenic sources of phosphorus going into local waterways. We have phosphate mining and fertilizer containing phosphate, which can lead to eutrophication, which is something we talked about last video. So it takes a really long time for phosphorus minerals to be weathered out of rocks and carried into soil and bodies of water. There's no gaseous phase of phosphorus, so it doesn't enter the atmosphere. And because it cycles so slowly, it is a limiting nutrient, meaning that plant growth and ecosystems is often limited by phosphorus availability in the soil and in the water. And just like nitrogen, phosphorus is needed by all organisms for DNA as well as ATP and for the construction of bone and tooth enamel in some animal species. Oh, hi, girly. Sorry, my cat might be meowing in the back of this video. So yes, phosphorus is going to be very slow in comparison to carbon and nitrogen. And the main natural source is going to be erosion. Wind and rain break down rock and phosphates, and that's released and dissolved into water. This is a very slow process. We should be a little bit familiar with weathering and erosion from our last unit. Weathering is very slow. It can take hundreds to thousands to millions of years. So because of that, phosphorus is a limiting nutrient. However, because of increased use of fertilizers due to the very prolific, or is that the right word? Pervasive agricultural industry, we have so many fertilizers being run off into local waterways. Runoff is when things are carried away by rain into local waterways, and those things carried away by rain tend to have pollutants or chemicals such as phosphorus that can cause eutrophication. So synthetic fertilizers containing phosphates are added to lawns, agricultural fields, and runoff carries that phosphorus into nearby bodies of water, causing eutrophication. So how does phosphorus get into plants and into rocks and soil? Assimilation is another term that we use in the phosphorus cycle as well as in the nitrogen cycle. Assimilation is when plants absorb phosphate from the ground and in the water. They absorb it through their roots and they use it in order to build DNA, make ATP. Mineralization is when organisms die, fungi and bacteria mineralize phosphate and it goes back into the soil. And geological uplifting is when phosphorus enters the ocean through precipitation or runoff, but it doesn't dissolve in the water. Instead, phosphorus is actually going to be deposited in the sediments at the bottom of the ocean. And geological uplifting is when the ocean layers are brought up to become mountains at convergent plate boundaries. And when you have this, you're going to have the rocks forming. They have phosphate in the rocks. And then when you have weather and rain, those rocks are going to be weathered and eroded over time, resulting in phosphorus to go back into the soil. So again, impacts of how humans impact the phosphorus cycle, the use of fertilizers, and also laundry detergent. Laundry detergent does have phosphorus in it, and when this is, cycled in the washing machine and then down our drain pipes and eventually into local waterways, it can cause eutrophication. Now let's talk about the water cycle, which is something that you should be the most familiar with, which is the movement of water between sources and sinks. And this is going to include all of the parts of the biosphere, including the atmosphere, the geosphere, the lithosphere, and the biosphere component. So water is a really important compound because it is very usable by all life on Earth in a solid, liquid, and gaseous form. So you just need to know the basics of how water gets through the different parts of the biosphere and the energy that's going to be driving this cycle, which is going to be the sun. So heat from the sun causes liquid water in the ocean to become a gas, which is called evaporation, when water is going from a liquid to a gas. And it's not just water in the ocean, it's also going to be water in any body of water or reservoir of water. So the ocean is the largest water reservoir. Our planet is majority salt water. Ice caps and groundwater are smaller reservoir, but contain fresh, usable water for humans. So the two main sources of water, which are the processes that cycle it from the liquid back on Earth into the atmosphere. So transpiration and evapotranspiration are the two main ways that water is put back into our atmosphere. So transpiration is the process that plants use to draw groundwater from roots up to their leaves. And some of these water that's brought up there is actually going to be transpired out of their leaves into the atmosphere. This is happening through the stomata. Evapotranspiration, very similar. The amount of water that enters the atmosphere from transpiration and evaporation combined. Evaporation is going to be the water that evaporates solely through... Oh, girly, what do you have? Oh, you have a little toy? Okay. I'm sorry. Excuse me. Evaporation is the water that is going to evaporate from bodies of water like the ocean, like lakes, and so on and so forth. And this is happening from the heat of the sun. So how are humans impacting the water cycle? This is something that we did cover a little bit in our previous unit when I was talking about aquifers, groundwater recharge, and impervious surface. So when it rains, that's precipitation. Water is usually going to flow over Earth's surface into a body of water. This is runoff. Or it trickles down into the soil into a groundwater aquifer. This is infiltration. So water will percolate through the soil and it, forms this underground reservoir of water, and we obtain most of our usable fresh water from the ground. Yeah, Gertie. So the groundwater, the aquifers, and surface waters are important freshwater reservoirs for humans and animals. Remember, salt water is not usable by plants or animals, or I should say most plants or freshwater plants cannot use salt water. We cannot use salt water. So the only way that we're getting a source of fresh water is using groundwater. So precipitation recharges groundwater through infiltration, but only if the ground is permeable, which means that water is able to pass through. We should know a little bit about impervious surfaces such as concrete, buildings, roadways. They prevent water from being recharged into the ground because the water cannot percolate or trickle through the soil to recharge our groundwater. And because of this, we also have increased amounts of runoff. So again, runoff is when water is being carried away, or it rains and water carries things away into a local waterway rather than into the ground. So when you have increased impervious surfaces, you also have more instances and increased instances of runoff. So anthropogenic contributors to the water cycle include deforestation and construction. Deforestation impacts the water cycle because there's not as many trees around to absorb the water to perform photosynthesis, and then you have less instances of transpiration, less water being evaporated through the leaves back into the atmosphere, and construction is going to result in increased impervious surfaces, resulting in decreased groundwater recharge. And I believe that's all I have for you guys today. Yeah. All right. So if you guys have any questions, please let me know. I will see you in our next class. Have a good day. Bye.